let's suppose we have something like negative 5 over 5. What's that equal to? It's equal to negative 1. Because we know that negative 5 is really negative 1 times 5, and we can cancel the 5's. Let's look at something like this now. X minus 5 over 5 minus x. Now we might ask yourself, how can you tell when numbers are opposites? Well, they would add together and make 0. 5 minus 5, 0. What happens when we add these two quantities together? X minus x is 0, and negative 5 plus 5 is 0. These two ideas are opposite. X minus 5 and 5 minus x are opposites. That is, we could write x minus 5 over negative 1 times x minus 5. You might think of this also as factoring out a negative 1. Then we could cancel, and we get a negative 1. We almost never leave negatives in the denominator. This is just equal to negative 1. So it looks like if the factors are opposites, when we cancel them, we leave behind a factor of negative 1. Let's see how that works in an actual problem. Suppose I have 12 minus x squared all over x squared minus 2x minus 3. Well, once again, the magic word is to factor. Can we factor the numerator? Let's see. This is really 12 and x squared. We could put an x and x here. And are there factors of 12 that make negative 1? Yes, 4 and 3. So we could put 4 here and 3 here. Which one do we want to be negative? This would give us 3x. This would give us 4x. So we want this to be negative and this to be positive. That'll give us positive 3x minus 4x equals negative x. It's kind of tricky sometimes to do these trinomials that look sort of backwards to us. Now let's try the denominator. X squared, 2x would be x squared like that. Factors of 3 must be 3 and 1. And signs would end up being negative and positive. You check that out by multiplying it back out. Now, what have we got? We've got x minus 3 and 3 minus x. You recognize those as being opposites? We'll cancel the x minus 3 with the 3 minus x. We'll leave a 1 behind down here, but we'll leave a negative 1 up here. Now we could write x plus 4 here without changing anything. The sense, we're just using the commutative property. And we've got x plus 1 on the bottom. So what we'd end up with is a final answer of negative x plus 4 over x plus 1. Now, do we want to remove the parentheses and distribute that negative sign? You may, or you may choose not to. Just be careful with your directions and how they're written to see whether or not you'd want to end up like that or not. And once we know how to put a rational expression into simplest or lowest terms, we can go ahead and apply the rules of arithmetic for multiplication and division and do that as well.